In this video, I'm going to show that the integral of 2y squared x minus 3 dx plus 2yx squared plus 4 dy is independent of path, and then go on and integrate along any convenient path between the 2 points 1, 2 and 3, 6. So we are given that integral there. The integral along the curve C of p dx plus q dy is independent of path if and only if the partial derivative of p with respect to y is equals to the partial derivative of q with respect to x. So in this case, we see that the coefficient of dx there is 2y squared x minus 3. And the coefficient of dx here is a p. So we see that our p there is 2y squared x minus 3. And then we go on and look at the dy. Here is 2y x squared plus 4, and here is the q. So we see that our q there is 2y x squared plus 4. And then we go on and evaluate the partial derivatives. We see that the partial derivative of p with respect to y is equals to 4xy, and the partial derivative of q with respect to x is equals to 4xy. So in this case, we are having that those partial derivatives are equal. And using this criteria here, we see that the partial derivatives are equal, so the integral is independent of path. So we have that that integral is independent of path. If the integral is independent of path, then we can evaluate the integral using any convenient path between the points 1, 2, and 3, 6. So whichever path we use, the result that we get will be the same. So in this tutorial, I'm going to look at some possible paths. So I'll look at path number 1. So we have our y and x-axis and the points there, 1, 3, then the 2, 6. So we look at the point 1, 2. The point 1, 2 is this one here, and the point 3, 6 is this one here. So we can move directly from 1, 2 to 3, 6 along this line here. So that's one possible path. I can look at another path. So I draw my axis and I put my point 1, 2. But from 1, 2, we can move to the point 3, 2. Then from 3, 2, then we move to the required point 3, 6. So I'm saying we move from 1, 2 to 3, then to 3, 6 there. Or the other option, I can have a path there. I draw my axis and I can start at my point 1, 2. Then from the point 1, 2, I can move to the point 1, 6. Then from the point 1, 6, I move to the point 3, 6. So we are moving vertically upwards and then move horizontally. So those are some possible paths that we have there, path 1, path 2, path 3. So in this tutorial, what I'm going to show is if we evaluate that integral along path 1, along path 2, along path 3, you will get the same result. But when you are evaluating the problems, you have to choose only one path which is convenient for you. In this tutorial, for illustrative purposes, I'm going to use all three paths. But when you are working the problem on your own, just choose one path which is convenient for you. So I start by the first path there, path 1, which is moving from the point 1, 2 to the point 3, 6. That's a straight line there. So we can find the equation of the straight line between the points 1, 2, and 3, 6. And the equation of that line there is y is equals to 2x. And then from that equation, we can obtain the derivative of y with respect to x. It gives us a 2. Then from that derivative, we can obtain our dy is equals to 2 dx. Substitute this information that we have obtained here. We substitute it into the integral there. And for x, we see that x is varying between 1 and 3. So we'll be having the integral from 1 to 3 of 2 times 2x squared times x minus 3 dx plus 2 times 2x times x squared plus 4 times 2 dx. And then when you go on and simplify, that will give us the integral from 1 to 3 of 16x cubed plus 5 dx. Then we can evaluate that integral and put the limits, and we will see that the result there is 330. So that's the result there when we have chosen path number 1. I can now go on and look at path number 2. For path number 2, we first move horizontally, then vertically upwards. We are having 2 different curves there for that path 2. So in this case, it is convenient to split our path C into parts C1 and C2. So the horizontal one, I'll call it C1. The vertical one, I'll call it C2. So our integral will become the integral along curve C1 plus the integral along curve C2. So we have the integral along curve C1, then plus the integral along the curve C2. So along C1 there, we see that y is equals to 2. Y is a constant, so we'll be having our dy is equals to 0. And we see that x is varying from 1 to 3. So if we substitute those values into this integral over C1, we'll be having the integral from 1 to 3 of 2 times 2 squared times x minus 3 dx plus 2 times x squared plus 4, then times 0. Then we look at curve C2. Along C2, we see that x is equals to 3. It's a constant, so dx will be 0, and y varies from 2 to 6. So substitute that into this integral here. We'll be having the integral from 2 to 6 of 2y squared multiplied by 3 minus 3 times 0 plus 2y multiplied by 3 squared plus 4 dy. So what is left now is to evaluate those integrals. For the first integral here, we see that it simplifies to the integral from 1 to 3 of 8x minus 3 dx. And this integral here will simplify to the integral from 2 to 6 of 18y plus 4 dy. For the value of the first integral there, when we integrate and put the limits, we'll get a 26. When we integrate this second one here and put in the limits, we'll get 304. So our result there will be 26 plus 304, and that will give us 330. So that's the result there when you are looking at path 2. I'll go on and look at path number 3. For path number 3, we are moving vertically, then horizontally. And again here, it is convenient to split the curve C into 2 parts, and those parts I'll call it C3 and C4. So for the vertical part, I'll call it C3, then the other one I'll call it C4. So our integral will then become the integral of the sum along those parts C3 and C4. So our integral will be the integral along the curve C3, then plus the integral along the curve C4. Then we go on and analyze those curves C3 and C4. What we see there is along curve C3, x is equals to 1. It's a constant, so the change in x is 0. We have our dx is 0. And y is varying from 2 to 6. So if we substitute that into this integral here, we'll be having the integral from 2 to 6 of 2y squared times 1 minus 3 times 0 plus 2y times 1 squared plus 4 dy. Then go on and look at curve C4. Along C4, we see that y is equals to 6. It's a constant, so the dy there will be 0, and x is varying from 1 to 3. So if we substitute that into this integral there along the curve C4, we'll be having the integral from 1 to 3 of 2 times 6 squared times x minus 3 dx plus 2 times 6 times x squared plus 4 times 0. And then we go on and evaluate those integrals there. For the first one, it will simplify to the integral from 2 to 6 of 2y plus 4 dy. The second one, it gives us the integral from 1 to 3 of 72x minus 3 dx. When we evaluate the first integral here, the result that we get there when we put the limits is 48. And when we evaluate this second one here, the result that we get when you put in those limits, we get 282. So what we are having there is the result there is 48 plus 282. And that will give us 330. So what you would have noted there is along path 1, we got 330. Along path 2, we got 330. Along path 3, we got 330. The results are all the same. This is expected just because we saw that the integral is independent of path. So if integrals are independent of path, you just choose one convenient path that is easier for you to evaluate that line integral.